Okay, so today we're going to be making an adaptive rock, paper, scissors game. So in this assignment, what we're going to do is the students have been asked to build a rock, paper, scissors game where the computer has a preference to choose rock, paper, or scissors that starts off even, but depending on what the player chooses, the computer will adapt its preferences to basically adapt to what the player is choosing more frequently, right? So what will happen is that if the player chooses rock, then the computer will adapt its paper preference upwards by 2% and its rock and scissors downwards by 1% to accommodate for that. So it's more likely the next time to pick paper. Now, this means that if your player has a preference to pick one of the three items, then the computer will try and will adapt and pick the counter item more frequently, right? Now, if the player just chooses at random, then essentially it'll be just random as well. So there's really no downside. Now, if the player knows that this is happening, they will be able to game the system perhaps by choosing like rock just continuously to kind of build the computer's preference and then suddenly switching to something else. But even then, I don't know if that would necessarily make any difference. It might be actually a good follow-up question to say, like, does this can you actually game the system? Is it actually, is there a way to, like, does choosing the same thing over and over again to build up the preference and then suddenly switching to the opposite thing suddenly like give you an advantage, because you'd have to lose a whole bunch of times to build up the preference, right? Anyways, let's just take a look. Let's start off. So we're going to start off by setting up our preferences. So what we're going to do is we're going to say int rock preference is equal to 33. That's 33% chance to choose rock. Okay, so we're going to do the same thing for the other ones. All right, so we got rock preference, paper preference, scissors preference. All right, now those only add up to 99, and it's supposed to be out of 100. So what I'm going to do is if I generate 100, I'm just going to regenerate the preferences, and that way it takes care of like any of those other that way we deal with that 1%. All right, there's other ways to deal with it. This is probably the easiest way to deal with it. Okay, or you could just make it out of 99. That would be fine as well. All right. Okay, so what we're going to do is we're going to start out by doing a prompt here. Okay, so we're going to say system.println, welcome to the rock, paper, scissors game. Okay, then we're going to say system.println, one rock. Okay, same thing. We'll just copy this here. Okay, it's going to be 2, 3, paper, and 3 will be scissors, of course. All right, then we're going to have a prompt here to say, please make your choice. Now, what we can do is I'm going to make this a print just because I want the input on the same line. Okay, now it's important to notice that the group of people I'm making this for don't know, they're beginners, since they don't know how to make methods or arrays or anything like that, and so everything has to be done sequentially. So just, some people in the comments might be like, oh, there's a totally easier way to do this. Yeah, I'm aware of that. There are other things. There are things that we can do to make this easier, but for a beginner, they might not understand those ways. All right, so let's take a look here. We're going to need a scanner. All right, so we set up our scanner there, have to import it. Okay, so we're going to say, we'll make a choice. So we'll say int player choice is equal to start off at 0, doesn't matter because we're going to see here player choice is equal to input dot next int. All right, so we've taken the choice. If you want, you could actually put in an error trap here. All right, and maybe I'll do that later if I feel like it or if I have time. All right. Okay, so we're going to input next int. Right now, I'm going to assume that the user has entered a choice from 1 to 3 with no errors. All right, so the next step is to generate the computer's choice. Now, how do we do that? All right, so what we're going to do is we're going to say that we're going to generate a number from 1 to 100. So we're going to say, okay, so random number. All right, so here I'm going to say int, I don't need to say that, random number is equal to math.random times, let's see, 100. Now, normally it would be max minus min plus 1. So that would be minus, we're going 1 to 100, so minus 1 plus 1. But minus 1 plus 1 is just 100. All right, so, okay. So, all right, so we're just going to do that. That's going to generate a number from 1 to 100. All right, and that's going to represent our computer's choice. All right, so now what we need to do is we need to check it to see if we're going to if what the computer generated. Okay, so if the computer generated a 100 though, that doesn't fall into any of our chances. So what I'll do is I'll just regenerate. Okay, so I'll say something like this: while random. This will have to be a do while. While random number is equal to 100. Okay, so whenever this generates a 100, it's just going to repeat and generate something else. I know that still skews the odds in some way, but it's whatever. Like, this is meant for beginners. It doesn't have to be totally mathematically sound, and it's just an RPS game. All right. So anyways, let's take a look. What do we do with this now? So now I have, at this point, I have a number that's going to be between 1 and 99 because the random number generator can't generate 100. If it does, it regenerates the number. So at this point, the random number is between 1 and 99. So what I'm going to do is I'm going to say if I'm going to need a computer choice here. And what I'm going to do is I'm going to make the computer's choices correspond to the player's choices. So 1 will be rock, 2 will be paper, 3 will be scissors, same as the player. Okay, so I'm going to say if random number is equal to 1, then, sorry, not 1. What am I thinking of? If the random number is less than or equal to the rock preference. Right, there we go. If it's less than or equal to the rock preference, then the computer's choice was equal to 1. That means the computer chose rock. All right. Now, so what we did here is because the rock preference is 33, if the number is, now the number is between 1 to 99 essentially, or 1 to 100 just regenerates. Okay, but then we have if random number is less than or equal to the rock preference, so 33, which will happen 1/3 of the time, then computer choice is equal to 1. Okay, then I'm going to say same thing. Now here's where most people will get kind of tripped up. And they'll say like, okay, well, how do I deal with this to get it to be 2, to be paper? Okay, so this means, what this means is if the number is less than or equal to 33, so on our number line, 1 to 33 is covered, but I need 34 to 66 to be covered, right? So what I'm going to do is I'm going to say rock preference plus paper preference, right? So now the number has to be less than the rock preference plus the paper preference, so that's 66 total. All right, so if it's 66 total, that means that, or then if it's 66 or less, then it'll choose 2. But then some people might say, oh, okay, well, what if it was 25 then? Well, if it was 25, that would have been picked up in here, and you would never get here at all, right? So the fact that you got to this else if statement means that it was not less than 33. All right, so, or it was not 33 or less. So this means automatically 66, 34 to 66. Okay, and if it wasn't any of these, then the computer choice must have been 3. Okay, so then it must have chosen scissors. All right, now at this point, what we're going to do is I'm just going to run and test this just to make sure it works. Okay, so a good practice is to test your code frequently. All right, so here I've got, you can tell a tiny text here, welcome to rock, paper, scissors game. Just for people's knowledge, like when I actually program, this is about the size that I actually program in. My console just has gigantic font here, just because it's easier for you guys to see it. All right, so anyways, welcome to the rock, paper, scissors. Oops, let's try that again. Welcome to rock, paper, scissors game. I'm going to choose a 1 for rock. Okay, seems to be working. What we should do here is have some if statements to say, add to these if statements to say what the computer chose. Computer chose rock. Okay, something like that. Okay. I'm just going to clean this up a little bit. Else, blah, blah, blah. Open scope. Get rid of that. Paste. Paste. Open scope. Okay, so computer choices 2. The computer chose paper. Computer chose scissors. Okay, let's go and just test this out over here and just see what happens a few times. So we're going to rock, computer chose scissors. All right, let's just see if the computer chooses other things. 2, computer chose paper. 3, computer chose rock. All right, so seems to be going good. Right, so the computer is choosing scissors, paper, so it's choosing different things. Okay, great. Everything seems to be working. It seems like it's working fine. All right. So let's label our sections. So this is title and prompt. Okay, this is generating the computer's choice. This is outputting the computer's choice to the user. Okay, and now the next thing we're going to do is calculate who won and who lost, or a win, a loss, or a tie. Okay, so there's a couple things that we can do here. We're going to need to also have scores here. So int player score is equal to 0. And computer score also equal to 0 to start. I'm going to add part of the title here. Okay, so I'm going to add just like nicer thing here. So actually, let's not do that. Let's just copy this line. Player plus player score plus computer plus computer score plus this. All right, let's see how that looks. Oh, error. Do I have probably an error with a bracket somewhere here? Yeah, I got an extra bracket there, or extra quote. Okay. Oh, that looks pretty terrible. Okay, so let's throw in a couple tabs, see if that looks a bit better. Okay, that's not the worst. See if we might be able to line this up a bit better. Yeah, that's okay. So what we'll do is just add 2 there. Okay, and maybe push this player 1 a bit forward. Let's see how that looks. Oh, it's not so bad. Maybe 1 tab here. Okay, that looks actually pretty good. And just one thing, a little nitpicky. There we go. Okay, so player computer 0, 0. Okay, so now we got to determine who won. All right, so who won? Okay, so essentially what this is just a bunch of if statements. So we're going to say if player choice is equal to 1, and now that means the player chose rock. So what we're going to do is we're going to check if the player won. Okay, so if the player choice is 1, it means they chose rock, and they will win if the computer chose scissors, right? So scissors is choice 3, so computer choice is equal to 3. All right, that is one way of winning. Okay, or now we're just going to copy this here. Now, if the player chose 2, that's paper, that means that the computer had to have chosen 1, that's rock. Okay, or the player could have chosen scissors, in which case they would win if the computer chose 2. All right, so let's see, do I have them all? The player has 1, 2, 3, computer has 3, 1, 2. Good, looks good. Okay, so okay, let me just check here. Okay, yeah, it looks good. All right, open scopes. This is why it's difficult sometimes to program in these gigantic things here, but I think I can move this safely over for you guys to be able to see more of the screen. Okay, so I've got a pretty giant if statement there. Okay, so that would mean that the player has won. So what we would do is we would do a system out print line, and say something like, you won. All right. And then what we can do is we're going to have to say player score plus plus. All right. And that should be fine. Now, here's the thing. If the player did not win, we can check to see if they lost. But to check if they lost, we'd have to basically do a gigantic if statement like this. But instead, what we can do is we can say if the player choice is equal to the computer choice. So instead of checking for the loss, we're going to check for the draw. All right, and we can do something like this. Okay, system out print line. It was a tie. All right. Now, the reason why is because if you didn't win and you didn't lose, or you didn't tie, that must mean you lost. So what we can do is we can actually just put the loss condition in an else statement, and we don't have to write all these other comparisons for the loss, right? So it just makes things easier. Okay, so system out, print line, you lost. All right, so just something like that. And then we're going to say computer score plus plus. All right, and yeah, that should basically work there. Okay, that is essentially the whole game. Now, it says in the problem that it has to go until either the player or the computer gets a score of 30. Okay, so how do we do that? All right, so what we do is we actually just bury this whole program into a do while. Okay, so we're gonna bury the whole thing into this do while statement. All right, just so you guys know also, if you're wondering why I'm always correcting my brackets, it's actually because in my classes, for beginner students, I actually believe that it's easier for them to visualize having the scope brackets like this, right, vertically aligned. But I understand the convention is like this. All right, so very often I'm used to programming with them vertically aligned, but I understand that the convention is like this. All right, so that's why I often have to correct it. Okay, so do. Let's see, is that the end of the do? Do I have my scopes all right? So do while if, yep, that's it. That should be paired up with that if statement. Yep, yep, yep. This one should be, that's weird. How come it didn't show that it's just paired up there? Oh, that's weird. Do I have, okay, that means I have one thing that's out here. What is, oh, okay. So here I did not have a closed scope bracket for that. Okay. Okay, good. So else choice 3, computer chose scissors. Determine who won. Okay, so now this is with the else statement, and this is a red line because I don't have the while loop. Okay, so there we go. Okay, so while computer score is less than 30, now, some people, when I observe them doing this, will say computer score is less than 30 or player score is less than 30. Now, the problem with this is that when the player score gets to 30, the computer score will, let's say the player got to 30 first. So now the player score gets to 30, the computer score, let's say, is 20. All right, well, that's still less than 30, so it's still going to loop. Now, if the same thing happens, let's say the computer gets to 30 first and the player score has like 28. Well, that's still less than 30, so this won't stop until both players have scores over 30. That's not what we're asked for. It's just when the first one has the score. So what we're actually looking for is an AND, right? That both of these have to be true in order to continue the game. So no one has won. All right. I don't want to play 30 times, so I'm just going to go something like 5. Okay, and let's see, is there an error? Error exists. Where is it? Extra scope bracket. There we go. Okay, let's take a look. Rock, paper, scissors. I'm just going to always choose rock. Okay, you lost. Welcome to rock, paper, scissors game. You lost. Okay, computer score is going up. And it actually, oh, tie. Okay, good. And actually, you can see it's actually pretty even, right? Like, so now I won. Okay, and there you go. So at first it was actually pretty even, and because I just kept choosing rock. And that actually kind of makes sense because if everything is just random, then if I just keep choosing the same thing, it actually makes sense that I would win and lose at almost the same rate. Right, and there was a bunch of ties in there and stuff like that too. So actually, I feel like this game is actually working correctly. So now that we have the basic game set up, how do we actually do anything here? So what happens here is after everything has been determined, but before you go back, okay, so before you go back, oh, I should do this, sorry. Check if it's a tie. And this is if you didn't win or tie, then you lost. Okay, so now what we're going to do is we're going to adapt to the player's choice. Okay, now how do we do that? Well, what we're going to do is we're going to say if the player choice was 1, that means the player chose rock. Okay, so what we want to do is we want to adapt and say, okay, if the player chose rock, then the rock percentage or rock preference, I believe, or is it percentage preference? Okay, so rock preference was now minus minus. Okay, so rock preference is going to go down by 1. And what we're going to do is we're going to say, okay, if the player chose rock, the computer wants to choose paper more. So paper preference plus equals 2. Okay, for those of you that don't know, saying plus equals 2 is the same as saying paper preference plus 2, like that. Okay, it's up to you if you, however you like it. I prefer just saying plus equals 2. Okay, and the scissors preference minus has to go down by 1. Okay. Okay, so rock, paper, scissors. So rock went down by 1, scissors went down by 1, but paper went up by 2. And you see, this will still work because over here, when we determine what was chosen, the rock preference now will be 32 or less, right? But the paper preference, right, will be between 33 and now this is going to be a 35. It will also be between 33 to 60, 68, right? So that's still a 30. So this will still account for the preference to choose paper. Okay. Now we basically just copy this. All right. So if the player choice was 2, now that means that they chose paper. That means the scissor preference is plus equals 2. And the paper preference went down by 1. Okay, and if it wasn't rock, paper, or scissors, okay, then if it wasn't rock or paper, then it had to be scissors. So if it wasn't 1 or 2, then it had to be 3. All right, so what do we do? So 3 is scissors. So that means the computer will prefer rock. So plus equals 2, and then these both should be minus. Okay, now what we can do is just, oh, and I just totally messed that up. I just fixed the wrong one there. Okay, so if they chose 3, that means scissors, the rock should be plus equals 2, and this one should be minus. Okay, so let's make sure in each of the choices, a different one should be plus equals 2. So this one's paper choice is plus equal 2, scissors choice is plus equal 2, rock preference choice is plus equals 2, and then the rest are all minus. That actually makes sense. Let's just do a quick check. So this is rock. If you choose rock a lot, then I want to choose paper more, which is this paper preference. If you choose paper a lot, which is option 2, I want to choose scissors more, right? That's this. And if you choose scissors more, then I want to choose rock more, which is what this is. Okay, so a very simple adaptation there. Okay, so let's take a look here and we'll run it. I'm going to go 5 times and we'll see what happens. It should, after a couple times choosing rock, the computer should be 10% more likely to choose paper. Okay, so I lost. Okay, so I won. And now it doesn't actually matter if I win. Okay, tie. Every time it ties, it gets worse for me though. Right? So the computer's just way more likely, right? It's hard to tell unless you actually print out or use the debugger or whatever to check to see. But it kind of makes sense now, like where if I just keep choosing the same thing, right, the computer is just more likely to win. Now I can still win, right? Now this is really bad, right? Like you can see, like how many times did I do this? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 times. It means that after all this, the computer is 28% more likely to choose paper because I keep choosing rock. 28% is quite a bit. Now, 20% more likely. It started at 33. It would have gone up by 28% over 14 rounds, which means that it would now be at 61% chance to choose paper over anything else, right? So you can see, like, this is why, like, if I bet you if we looked at it, the computer would just actually start winning more and more often, to the point where the rock score would actually just like go over 100. That's actually something that we should maybe deal with if we have time here at the end. Like, what do you do if the rock score, like if one of these goes below 0? Right? Like, can you have like actually a negative number, right? Like, I don't think I think we should set a maximum, right? So what we can do here is we can say, look, none of these can go below 0, right? So we'd also have to say, well, we can just deal with that later. Well, let's deal with it now. Okay, so we're going to say player choice is equal to 1, and well, actually, let's deal with it later. I'll put a to-do here. What if a score goes below 0? Okay, or not a score, a preference. Okay, so we don't want the preferences to ever go below 0. All right, but I mean, that's something that's more advanced, and if a student didn't actually consider that, then I'd be okay with it, right? Okay, here we go. This is going to be 30, 30. Now, I know the game works, so that's fine. Okay, so we have the adaptive part here. Now, the last part is that it says that there's a 15% of the 15% chance that the computer will just outright cheat. All right, so what we're going to do here is in this section here, we're going to put cheating. All right, so how do we do that? What we're going to do is we're going to say if, and just take this. Okay, if math.random is less than 0.15, or say less than or equal to, that's a 15% chance of this happening. Okay, then we're going to cheat. Okay, so we're going to say if player choice is equal to, let me just see here. Yep, player choice is equal to 1, then computer choice actually, we can just copy the code from over here. So this means if the player chose rock, that we want the computer to choose scissors. Okay, sorry, paper. Okay, that means that, so the player chose rock, computer chose paper. Okay, and that they will lose. All right. Else if player choice is equal to 2. Okay, so if the player chose 2, then that means they chose paper. We want to choose scissors just to outright cheat them. All right, and otherwise, if the player didn't choose 1 or 2, that means they must have chosen 3. Okay, that means we need to choose rock. Okay, it means they chose scissors, so we chose rock. Now, for testing, what I will do is I will actually put a note here. This is just a test code. Cheated. Okay, just so we can see that it actually happened. Okay, so we have this if statement here. If the player chose, if the random number is between is 15% or less, then we go into the cheating mode, in which case we just choose whatever it beats our opponent. All right. Now, what we're going to do here is we're going to say, we're going to put all of these into an else statement. Okay, so this is to make it so that the computer doesn't redirect it and undo our cheating by just looking at the random number. All right, so it only checks, this is if it's cheating, This is if it's not cheating. All right, and that should pretty much cover that. Let's take a look. So we're going to play a bit. Rock, computer chose rock, it was a tie, okay. Rock, I won. Okay. Still looking for a cheat. Okay. Okay. Let me just see here. So far, no cheating. Oh, there it is. Almost missed it. Yeah. Okay, so the computer cheated. Now, 15% of the time is, about 1/7, right? So how many games did we play before it cheated? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's a little bit weird. Let's just keep going here. No, there's another one. Okay. So I think it was just some luck. Yeah, there's another one. So it is cheating like fairly often here now. Like it's about at the right rate. Okay. I was a little bit concerned because like whenever you're coding, you should always ask like, is the program behaving as you would expect? Right? In this case, it is behaving as I expected. Well, when I first ran it, it was like 20. I knew it was a lot of times, but 21 times and only cheated once. And when you're expecting 1 in 7, that's not very good. But then you can see here, it kind of started making up for it and just cheating more often. So I think it was just a bad luck thing that it just didn't choose that number for a while. Right? And that can happen. Okay, so it looks like it's working. All right, and so far this whole thing is finished. All right, well, let's go back and fix some of these things, like a couple of the to-dos here. So the first one is, what if the preference goes below 0? Okay, so how do we deal with that? Okay, so the way we deal with this, all right, is we're going to say, look, there's going to be a maximum choice, right, where we cannot, any of these cannot go below 0. Okay, so we're going to say if player choice is equal to 1 and the rock preference is greater than, let's say it always has to be at least 1%. Okay, has to be greater than 1. Okay, and the scissors preference also has to be greater than 1. All right, so basically what this does is it makes it so that if either of these rock preference or scissors preference is at 1, then this just won't happen, right? So this has to be more than 1, and also this has to be more than 1, right? And before this can go down. All right. Same thing over here. Okay, so we will just modify this as well. So we'll say and. Okay, so rock, and I can't spell rock. Preference is greater than 1, but in this case, the paper preference has to also be greater than 1. All right, and in this case, so now we had an else before, but we have to say else if paper preference greater than 1 and scissors preference greater than 1. Okay, now here's the thing. Do I have to say player choice is 3? I think I do. And the reason why is because now, before when it's not 1, if it's not 1 and it's not 2, then it must be 3. But because we've added extra conditions, it could have been 1 and not these things. And so just having an else here without checking the player condition means that like there's a chance it could go into this section here just because these two conditions didn't get met. So now you have to add this back in. Okay, but now because it will only decrease the paper or scissors preference if they're both 2. All all right, or 2 or higher. Same thing here, rock and paper preferences have to be 2 or higher, and over here, rock and scissors preference has to be 2 or higher. Otherwise, just nothing happens. And that will establish it so that essentially there's a lower limit to what the preferences can be, and that's always at 1%. All right. Okay, last thing, because we have a little bit of time, is this add error trap here. All right. So what we're going to do is we are going to say Boolean input success is equal to true. Okay, we'll say do. Okay, set input. Okay, I might as well go over this for those of you guys that don't understand this. Okay, so what we're going to do with this error trap is we're going to test to make sure that the user actually enters a number between 1 and 3, right? And also that they didn't enter text or something like that. That's just going to break the program. So what we're going to do is we're going to say try, okay? And by saying try, we're going to acknowledge that something could go wrong. When you try, it means that you acknowledge that something might not work. Okay, so we're going to say this. Try player choice, and let's actually throw the prompt in there too, just to so that the user will know what's happening here. Okay, so try this. Okay, and we're going to catch. We'll just catch all exceptions. All right. Now, the only real exception we're really concerned about when working with the console like this is that the user is not going to enter. They are going to enter something that's not an integer, right? So that will make the computer reject the input. All right. So what we're going to do here is we are going to say input success was equal to false. Okay. So now the input success is false, but then we still have the data stuck in the stream. So what we're going to do is we're going to say string garbage is equal to input dot next. Just make a garbage variable. It's going to read the next input from the stream and just throw it away. All right. At the top of when we loop back, we're going to have to reset the input success back to be true. Okay, and here we will just say do this while input success is equal to false. And that's a single equal sign. Okay. Now, what we can do is also at the same time verify that the numbers between 1 and 3. So what we're going to do is we're going to say if input success is equal to true, meaning that they did enter a number, then the number was accepted. Okay. And okay, so now what we're going to do is say that the player choice was less than 1, or player choice is less than or greater than 3. All right. Now the order of this actually matters. All right, because if the input success is not true, then you cannot actually really check these, or there's no point in checking these, right? So because we put this first, if the input success was not successful, then it won't check the second half of the equation, right? So it's better just to do it this way. All right. So if they chose less than 1 or greater than 3, then it's and the input was good, then that means that they had input success being false. All right, and I think that should be it there. Let's test out that error trap. Okay, so please make your choice. Put in some random digits. 9, nope. How about 2? Nope. 4, nope. 0, nope. 3, good. Okay, looks good there. Okay, just add some spacing here, just so I think it'll look a little bit nicer. Yep, there we go. And I think that is essentially the whole thing, right? That's the whole program. All right. And that's pretty much it. Now, just one thing also before I sign off with you guys here is one thing a lot of people do with error trap algorithms is that they actually build the whole program into it. So you can see what I've done here is that the error trap it starts here on line 26, although you can't see the line numbers. It starts here and it ends here. So it's actually encapsulated in this one block. What a lot of people will do is they'll start burying like these things inside of it. Don't do that, all right? Because basically what you want to do is you want to compartmentalize as much of your code as you can. Because if there's ever a problem, if the two or more sections are enmeshed together unnecessarily, it's very difficult to debug them, right? So because this section here just does one thing, if I'm trying to debug it, it is only this section that I have to check. All right. Same thing here, generating the random numbers is just in this section. So if anything's wrong with that, I only need to check or change here. Same thing with cheating, just in this section. Character choice, computer choice is just this section, and so on and so forth. So I've compartmentalized all my code to make it easier for me to actually verify that, to debug or make changes or add things. If you enmesh them, you mix them and intertwine them together, it will be very difficult later on to extricate them, like to get them apart. And if something goes wrong and you need to make a change, it's going to be very difficult to change it, or potentially difficult to change it. All right, so that is the adaptive rock, paper, scissors game. All right, so if you guys have any questions, throw them into the comments. Hopefully this was informative and helpful to you. Thanks for watching. Have a great day.